Yeah, in this session I will focus on interfaces. Interfaces are similar to classes, but they lack instance variables. We have discussed the general form of classes, class, class name. Then this is followed by the opening curly brace. Then within this definition of a class, we need to specify the instance variables and the method declarations. That is a general form of a class. Class name, opening curly brace, instance variable declaration, then method declaration, then you need to close using the closing curly brace. Inside the class, we can specify instance variables and we can specify method declarations, right? And method definitions can also be provided. In case of abstract classes, method declarations. If not, you need to specify the complete method definitions inside the class. Let's go. And the concept of interfaces are similar to classes. Only thing is interfaces lack instance variables. Interfaces do not have any instance variables because the logic of interface is to achieve one interface multiple methods aspect of an polymorphism. In general, interfaces contain method declarations and variables. The variables must be initialized. The variables are by default implicitly static and final variables. That means the variables must be initialized. Suppose inside the interface, if we define one variable, say int x is equal to 20, by default the variable integer x is of type static and final one. Data type is integer one. By default, the type applied to the integer variable x is static as well as final. So interfaces lack instance variables. Method declarations are to be provided like abstract classes. Method definitions right, should not be provided. The keyword to define the interface is interface. So in general, right, the syntax to define the interface is this one. Access specifier. The access specifier defines a private, public, and protected mode. By default, the access specifier of an interface is public one, public with respect to the same package. Interface is the keyboard. The name of the interface is provided right following the interface keyboard. So access specifier, then interface, name of the interface. Inside the interface, right, what we can do means we can define the variables, right? Variables declaration. Variables can be declared using this general form. Type final variable is equal to value. Then type 1 final variable is equal to value. Type 2 final variable is equal to value, etc. You can declare any n number of variables. All variables must be initialized by default. If you miss the type of static and final, the variables are implicitly taken as static and final variables, which means that a final variable, it cannot change the content of a final variable. And methods can be declared like abstract classes using this general form. Return type, method name, parameter list. Like abstract class methods, we can declare the methods. So what is the purpose of interface, right? Once an interface is defined like this, having some variables and methods declaration, the interface can be implemented in any number of classes to achieve this concept. One interface, multiple methods. Whenever the class implements an interface, the implemented class must provide its own definition corresponding to the interface methods. So by default the interface access specifier is public with respect to the same package in which it is defined. Variables are of right. Recall that the variables, the interface variables are by default static and final. The variables must be initialized one. All methods and variables are implicitly public. Even here, variables access specifier is missing. Methods access specifier is missing. By default, all the methods and variables are implicitly right a public access to. Once an interface is defined, the interface can be implemented in any number of classes. Or a class can implement an interface, right? A class can implement an interface. A class can also implement more than one interfaces. When a class likes to implement more than one interfaces, the interfaces names, right, are separated by the comma operator. When a class implements an interface, we need to use the implements keyword, right? A class name, implements, then interface name, then define the implemented class definition. So when a class implements an interface, the class must implement all methods of the interface. Assuming that an interface, right, I consists of 5 methods. A class C is going to implement the interface I. That stage, the implemented class, right, C must implement, must redefine all of the 5 methods declared in that interface, right? In case if it fails to redefine at least one definition of the interface method, then you need to declare or you have to make the classes an abstract one. Another important rule is when you implement the interface method, there must be there must be the exact type signature followed from the interface method declaration to the implemented class interface method definition. Return type, method name, parameter list, semicolon. The same type signature should be redefined in the corresponding implemented class. So the implemented class must redefine all methods of the interface. In case if it fails to redefine at least one method, then the class can be made as an abstract one. So as usual, right, abstract classes cannot be inherited. Abstract classes cannot be instantiated. You can inherit, right, extend the abstract classes so that the extended classes can access the features of abstract class. The implemented class, right, the interface implemented class may also have additional methods called non-interface methods. Because the interface contains some methods, when the interface is implemented in a particular class, the implemented class must redefine all methods of that interface. So in that stage, right, the implemented class may also have some additional methods other than the interface methods. Those are said to be non-interface methods. You can create reference variables for the interfaces using this general form. Interface name, then interface reference variable list. Reference variable list is a list of variables which are separated by the comma operator. Interface reference variable can assign the implemented class object. So having the creation of interface reference variable, this variable can be assigned the corresponding interface implemented class object. Interface methods, when you redefine the interface methods in the implemented class, the implemented class must redefine or must redeclare the methods as public one. This is a rule. Interface I1, suppose void M1. When the interface I1 is implemented in a class C1, void M1 should be redefined in C1 as public void M1. Then the definition of M1 must be provided. This is a rule. Interface methods must be defined in the implemented class using public access specifier. To access the interface methods, right, there are two possibilities. One, you can create an object of the interface, right? Or you can create an object of the interface implemented class. So once you can create an object of the interface implemented class, using that object, we can access the corresponding interface method, right? A normal rule. Otherwise, you can create a reference variable of the interface name, then create an object of the implemented class, assign the object of an implemented class to the reference variable. So interface reference variable is equal to the implemented class object. Then interface reference variable can have the rights to access the corresponding interface method. These are the two possibilities in which the interface methods are called. One, using the object of the implemented class, right? Straightforward. Second, you need to create an interface reference variable. That interface reference variable should be assigned to the corresponding implemented class object. Then, using that interface reference variable, we can only access the corresponding interface methods. But using interface reference variable, you cannot access any non-interface methods which are defined in the implemented class. So this stage, the general form of a class with respect to inheritance and interface. That means a class when extends a superclass and performs implementing interface operation, right? That stage, the general form is represented with class, class name, extends a superclass. That means here class name, right? This is a subclass name. Extends a superclass name. Then following this, if the class likes to implement the interface list, then it should be represented like this. Implements interface list. Then variables declaration, methods declaration corresponding to this class, new class name. So this class name implements one feature from the superclass and another one feature from the interface list, or more than one interface list, right? More than one interfaces which are separated by the comma operator. So it seems that multiple features are inherited into right in a single class. So thereby Java indirectly achieves the concept of multiple inheritance using interface concept. So the purpose is to achieve a multiple inheritance. Second one, to achieve a runtime polymorphism, that is one interface, multiple methods. Once an interface is defined with one method, that method can be redefined in the corresponding implemented classes in the different way. Each class can redefine its implementation in a unique way, right? So it achieves one interface, multiple methods. There are certain changes from the basic concept of interfaces to the recent versions of JDK. Right, in JDK 8, it adds a default implementation to an interface method. So far, we have discussed the interfaces uh, lack the method definition. Right, we have said that only method declarations are allowed inside the interface. But in the latest JDK version, say JDK 8, you can provide a default implementation of an interface method. Second, in JDK 8, right, you can add static interface methods. In JDK 9, the extended feature is you can include private methods inside the interface so that the private methods can be accessible in any of the interface default methods. Later, right, we explore the features available in JDK 8 and JDK 9. So just think now, interface is similar to a class which likes instance variables. The interface variables must be assigned a value because by default the interface variables are static and final type. Interface defined right declare methods like return type method name parameter list. Like abstract class methods, interface methods are declared. The interface can be implemented in the corresponding class. A class can implement one interface or a class can implement more than one interfaces. Also, one interface can be implemented in more than one classes, right? A class can also perform inheritance concept, right? Extending inheritance, right? Extending the superclass and at the same time implementing the interface operation. So that stage, the general form of a class is changed to this one. So inheritance first, then interface second, right? Now let us verify the rules of interfaces in Java. Have a look into this code. Class C. The C is one class, right? The definition of class C is missing here. For example, we can define the members of C here. Members of class. Then one interface is defined. Interface sample IF. That means access specifier is missing. By default, the interfaces are public access to with respect to the same package. Int strength is equal to 80. Static the final, right? The rows are missing, so it seems that int strength is equal to 80 is same as static final int strength is equal to 80. Since strength is equal to 18, right? As strength is a final variable, you cannot change the value of a final variable in the implemented class. Boolean, for example, listen class is equal to true. This is a Boolean variable. Variable right must be initialized. For example, it is initialized to true. double x is equal to 1.2. X is a double variable initialized to 1.2. Then void m1, void m2. Some methods are declared. M1 and M2 are said to be interface methods called sample IF methods. In case if we define void M3 something, right, this will result in compile time error because later, right, we explore default method definition can be provided using a default keyword, right, we will explore later. So as of now, right, void M3 something, this results in a compile time error because interfaces lack the corresponding method definition. This is a sample interface having some variables with a final and a static initialization, and then two methods are declared. Whenever a class implements this interface, that is the role of the class to redefine the complete methods of sample IM. For example, class sample IM PLIF extends C implements sample IM. So at this stage, right, what happens means this is a new class. The new class likes to perform inheritance on class C, extends class C, then implements the corresponding interface. Interface name is sample IF. Sample IF is the interface name. Now it defines some additional numbers. Say int a is equal to 5. Int a is equal to 5, a is one integer variable and the value is assigned to 5. This is a normal class. Then public void m1. What is void m1, void m2? Void m1, void m2. These are the methods declarations provided in the interface. Since the sample IMPLIF implements the sample interface, this class must redefine all interface methods. Void m1 should be redefined. Void m2 should be redefined. We have redefined void m1. When you redefine void m1 here, this will be preceded by a public access specifier. Public void m1. All interface methods are defined in the implemented class. That stage, the access specifier of the method definition is public. Explicitly, we need to specify public using public access specifier. Public void m1. So inside this data, you can access the variable C strength, listen class, the variable C6, then its own variable B. Incrementing strength by 1, strength plus plus, this results in a compile time error because interface variables are by default static and finite. You cannot modify its value. Second method, public void m2. For example, here we have provided a dummy definition, no executable statements. Since the class sample IMPLIF extends C and implements sample IF, sample IF or two interface methods are redefined here. Since this is an implemented class which extends a superclass, right? And at the same time, it can have some additional methods. The additional methods are said to be non-interface methods. Say void F. What is F? F is not even defined in C. F is not even defined in sample IF. So F is said to be a non-interface method. So non-interface methods can have the rights to access the corresponding interface variables and the additional variable of its own class. So same thing, right? Strength, listen class, right? Then the variables x and e are written. Now have a look into, right, this class sample IMPLIF. This is an implemented class. How to access the corresponding interface methods using the implemented class, right? That is the question. So for that, right, there are two ways. One, as usual, you need to create an object of this sample IMPL a class, sample IMPL IF class. So creating an object of this implemented class, interface implemented class, class name, object name is equal to new, the corresponding interface implemented a class. Then object name dot m1, object name dot m, object name dot m1, right? Okay, object name dot m2, object name dot f. These are accessible. The second possible way to access the corresponding interface methods in the implemented class is twofold. One, you need to create the interface reference variable, two-step process. For interface reference variable, sample IF, we have created one reference variable, for example, siref1. Siref1 can point the implemented class object. Implemented class object is say SOBJ. Now you can access SOBJ, you can access S1iref1 siref1 dot m1 because m1 is an interface method written. This can be called using interface reference variable. Siref1 dot m2, that is valid, but siref1 dot f is invalid because siref1 is an interface reference variable. When the interface reference variable is pointing the implemented class object, interface reference variable can access only the methods declared in the interface. Since f is a non-interface method, right? This is a non-interface method. Non-interface methods cannot be accessible using the interface reference variable. Now have a look into the compilation of this file. Java C interface ref2.java Java then interface to running the code, we are getting the result. For example, strength is equal to listen, class is equal to then variable x and the value of e, right? Thrice, right, corresponding to here s object dot what is our method m1, right? M1 is printed here called then sobj dot f here the same variables are printed. Then here siref1 dot m1 using interface reference variable, we are trying to call a method m1. So using interface reference variable, we can call only the methods which are having the scope of that interface. This means non-interface methods cannot be called using interface reference variable. So let us try to call a non-interface method named f using interface reference variable. What happens? This is an error message. Wait 1 minute. This will be commented. So commenting the non-interface methods, decompiling. What is the error message? Location variable is iref1 of type sample layer. Error cannot find symbol. So yes, iref1, the interface reference variable, cannot find what is f. F is not defined in the sample interface. So this results in the compile time error. So understand clearly the interface features in the implemented class are accessed using two ways. One, using the implemented class object normal root object name dot method name. Second one, you try to create the interface reference variable and create an object of implemented class. Assign the statement interface reference variable is equal to implemented class object. Then interface reference variable dot the corresponding interface. See the next code interface 3.java. Say in this what we have done, one interface I1 is defined interface I1 by default. This results in a public interface. One static as well as final variable by default is defined int x is equal to 20. Declaring character y, this results in a compile time error because what is y? Interface variables must be initialized a value, right? So even if you miss static and final, no problem. By default, this is taken as static and final. All interface variables must be initialized. Final static and final can be interchanged nodes. Float f is equal to some initialization. Static final double z. This results in error because what is z? Z is not initialized value. right? This results in error. Next, class C1 would like to implement the features of I1. Class C1, so write a code this way. Class name, inheritance is missing, right? Inheritance is an optional one. Class C1 implements the interface name I1. Then interface method, right? No interface method. This is a non-interface method, right? Non-interface method tries to access the interface instance variables. X is equal to x plus y means are an error because x is a static as well as final variable. You cannot modify the value of static does not, you cannot modify the value of final variables. So printing the value of x, right? Correct. And printing the value of f. F results in initialization, right? 5.7. Printing the value of z. This results in a compile time error because here z has not yet been initialized. Then class interface 3, we are creating an object of C1 and we are trying to call C1 obj.display. Now let us compile this code. Java C interface 3.java Java interface 3. Value of f is printed. Just to check if character y, what happens? Character y error is equal to expected. That means you need to initialize the value of a variable y. Static final double. Let us check it. Java C, I think interface 3.java. Static final double is it error. This should be commented. Recompiling. Core error. Static final double is it. After that, right? You need to do the corresponding initialization. Initialization is missing. So carefully understand interface variables must be initialized by default. The variables are static and the final one. Here, if you try to write x is equal to x plus y, we check it. Modifying the value of interface variables result in a compile time error because by default interface variables are static as well as final one. Final variables cannot be modified. Now consider the next example, say interface 4. On interface I2 is defined int x is equal to 20. By default, this is static and the final variable. M1 and M2 are declared, right? Additionally, M1 and M2 are declared. Class C2 implements I2. Void disk. Here we like to print the value of x and f. Then int c is equal to 12, right? What is int c, right? Following the method declaration, we are providing some variable initialization. Int c is equal to 12. This is the instance variable of class C2. Then, since the class implements the interface I2, M1 and M2 definitions must be provided here. Public void M1, for example, x plus y is printed. Public void M2, c plus x is printed, right? What is x? X is 20. 20 plus y 25. Then here c. What is c? C is 12 and x is 20. 12 plus 20, right? 32 is printed. Then interface 4, on the first logic, right? We try to create an object of C2. C2 object is equal to new C2. Using C2 object, we can call interface methods as well as its own methods. So C object dot M1, C object dot M2, then the C object dot disk. Disk is a non-interface method because an object can have the rights to call its own methods, right? Here the methods are by default the public access to. So C2 object can have the rights to call the three methods M1, M2 and this. How to access the interface methods M1 and M2 using interface reference variable that we have seen earlier, right? I2, what is I2? I2 is the interface name. I2 ref is equal to new I2. You are trying to create an instance, right, object for the interface. I2 ref is equal to new I2. This results in a compile time error. You cannot create object for interfaces, but you can create only a reference variable I2 I2ref. I2ref can be subsequently assigned to the implemented class object, say C2 object, or in a single step you can write, right? These two steps can be provided in a single line. I2 I2ref is equal to C2 object, creating a reference variable for an interface, and at the same time this is assigned to the implemented class object. Or I2 I2ref is equal to, then you can provide the implemented class object, say implemented class object, right? Implemented class object as created right in the previous step. Then I2 ref dot M1, I2 ref dot M2, I2 ref dot disk. M1 and M2 alone, the interface methods. This is not an interface method. So trying to call the non-interface method using the interface reference variable, that results in a compile time error. You can see the message. This is not in I2. I2 I2 ref is equal to new C2. This is valid. Here I2 I2 ref is equal to C2 obj, or in a single line you can write it this way. I2 I2 ref 1 is equal to new C2. The object should have created previously, otherwise you can simply call the constructor new C2. Then I2 ref dot ref 1 dot M1, I2 ref 1 dot M2, right? These are valid statements because I2 ref 1, the interface reference variable, can have the rights to access only its own methods, right? So I2 ref 1 dot M1, I2 ref 1 dot M2. These are valid method calls. Let us check it. Java C interface 4.java, then Java interface values of x f like x plus y c plus x. These are printed with respect to our valid method calls. You try to write check these lines, right? These lines result in the compile time error. Next one interface 5.java. In this right, we like to define one interface say shape, interface shape. Then define one instance variable int l is equal to 25. Void compute area. Then you can define write your own implemented classes. You can also pack this as a package, right? In case if you want to create a package including interface, right? Here what you have to do means you need to provide a package statement, package. Then following that, right, you can define a prepared some import statements, import some package named as star. Interface shape is an interface defining one integer variable int l is equal to 25. Missing final static, so by default this is final as well as static integer variable. Value is set to 25. Class rectangle implements shape. Class rectangle, right? A new class implements shape. A class rectangle can have its own instance variable, say int area comma b is equal to 10. Public void compute area. So clearly type signature is matching with the interface method name. Void compute area, no parameter list. Void compute area, no parameter list. So this is clearly the interface method. Area is equal to, for example, L star B. L is an interface variable and B is a rectangle class instance variable. Void display, this is a non-interface method. This tries to print the value of the class instance variable area. Area is area. Defining the another class, say interface file, using two possible ways. We try to call the compute area. So create one rectangle class object. Rectangle R is equal to new rectangle. Then you can call R dot compute area. If not, create one reference variable shape is create an object of rectangle class. Assign the statement sref is equal to R. Then call sref dot compute area. The interface method is called. Sref dot display is not possible because display is a non-interface method. Cannot be accessible using the interface reference variable. Then R dot display, R dot compute area, right? These are valid statement. R dot display, R dot compute area, right? A valid statement. If not, you can create this way. Shape. A shape reference variable is equal to new rectangle sref 1 dot compute area and rectangle r2 is equal to new rectangle r2 dot display. Right. So try to learn the accessing rules of interface instance variables and interface methods. Interface methods can be accessible right using the implemented class object. If not, using the interface reference variable and when the interface reference variable is assigning the implemented class object, you can use interface reference variable with the dot operator to access the corresponding interface method. So in this example, we have illustrated only one interface and one class that implements the corresponding interface. Interface variables and methods are accessible here. Compiling the code Java C interface 5.java, then running the code Java interface 5 area is written twice. We have called this one r dot display and r dot display displays the value of the computed area. The next example interface 6. We do like to focus on the runtime polymorphism. As we discussed earlier, using the shape abstract class, how Java achieved the runtime polymorphism. Here we do like to create an interface called shape. The method is to be declared is compute area. The implemented class right should redefine the corresponding compute area method. Let us assume some implemented classes circle, rectangle, triangle. The focus is to compute the area of 2D objects using runtime polymorphism. Similar to abstract class concept here, the abstract class is replaced by the interface. Abstract class shape is replaced by interface. There we define the abstract double compute area, right? So the thing is replaced by interface. Interface name, then double area is equal to 0, or you can define static final double area is equal to 0 if preferred. Double compute area, right? Only one interface method which is declared. Whenever a class implements this interface shape, that you must redefine the compute area method with respect to this type signature. So class circle, right, likes to implement this interface shape. Class circle implements shape. Some instance variables constructor are declared here. The interface method double compute area is redefined here. Public double compute area. Return. The area of a circle is computed and return. Likewise, the class rectangle implements the same interface shape. The rectangle area is computed by redefining double compute area. Likewise, in a class a triangle, right? You can do like this. Here, you can define a class triangle which implements the shape. Then you can try to find the area of the triangle. Then in the main method, you can create an object of this interface. Shape is an interface, so you can create a reference variable of this interface. And what is a reference variable? sref. Shape sref. Then create the objects for the corresponding implemented classes, circle and rectangle. Then you can point sref is equal to cobj. This stage if you call sref dot compute area, currently sref is pointing the circle class object, so corresponding area of circle is computed. Then the same statement sref dot compute area, this calls the area of rectangle class because currently the interface reference variable sref is pointing the rectangle class object. As we discussed earlier, right, using dynamic method dispatch, how Java achieved the runtime polymorphism, right? Same statement, similar to buy a ticket, right? At different situations, how right we are responding, right? Differently. The same way, at a different situation here, sref.compute calls the area of circle, and here sref.compute area calls the area of rectangle. That is, the versions available in the different classes are going to be called at runtime. That's what interfaces are helpful in achieving runtime polymorphism in Java. To do that, We need to create an interface reference variable. Interface reference variable should be assigning the implemented class object. Using the interface reference variable, call the corresponding interface method. Then the right version, right, which is actually pointing the current object, right, in that class version is going to be called. Thereby, Java achieves one interface multiple steps of runtime polymorphism. Compiling this code, Java C interface Java, running the program Java interface area circle, area of rectangle is printed. Only one statement, this highlighted statement, right, calls the person available in different classes, and this kind of method dispatch are determined at runtime. That's what interfaces are useful in achieving runtime polymorphism. Same class here, I think interface 7, interface one shape. The method is declared, right, the same class. Here new thing, right, one class x is declared. Class x, right, having one small variable, say double x instance variable. The class circle at the same time, right, extending the superclass, right, x, implementing the interface name shape. So it seems that the class circle extracts the features from two superclasses. Class x, right, can be equivalent to one superclass, and the shape, right, interface similar to a class because it takes on the instance variables and method definition. So that's it. If you think this is a class, right? So multiple features of different classes are inherited into a single class to achieve a concept multiple inheritance. So in this slide, you can create an object of a circle class and a rectangle class to call the compute area methods. Or you can create the interface reference variable of this shape. Then shape can be assigned to the object of circle and rectangle. Then using one interface, multiple methods. As we see in the previous example, sref.compute area calls the versions available in different classes. Before that, you have to make an assignment statement. Which object should be pointing actually to the interface reference variable? Yes, sir. Here also, right, you will be getting the same result. Java C interface 7.java Java interface 7 area and area of circle and area of rectangle are printed, right, having the same result. But at the same time, right, the implemented class may also perform inheritance by extending features from some superclass or to achieve a concept of a multiple inheritance. Another one is how can you extend the interfaces, right? That is the question. Can in one interface be extended in another interface? Or is it possible for an interface, right, to achieve the inheritance concept, to apply inheritance concept? Yes, interfaces can be extended. That means it can perform inheritance with respect to interfaces. The rule is very simple. One interface I1 is declared having two methods, right? So M1 and M2. When interface I2 extends I1, what is the meaning? New interface I2 is derived by extending the features from I1. So that stage, the interface I1 methods are, right, available inside the class I2. So whenever a new class, right, that implements the interface I2, that new class must redefine all methods of I2 plus the methods declared in I1, right? Because I2 is extended from I1. I2 is having three methods. I1 is having two methods. 3 plus 2, 5 methods must be redefined in the implemented class that implements the interface I2. Say class IMPLZ implements I2. 5 methods corresponding to I1 and corresponding to I2. All the 5 methods are declared here. public void m1, m2, m3, m4, m5. In case if you try to miswrite any of these try to write miss any of these method declarations here, definition is missing means that says what will happen is this class should be declared as an abstract one, abstract class IFPL is that implement cycle. That means there is a partial implementation of an interfaces. At least when one interface method is missing, right? What happens? The implemented class is taken as the partial implementation of an interface. The implemented class should be declared as abstract class. Now having the implemented class IMPL is that implements all of these interface methods, right? Both I1 and I2. Now you can create an object of IMPL is that using the object you can call M1, M2, M3, M4, M5, right? And carefully look into this line I2, I2 ref. For the second interface, we are creating a reference variable. When the second interface reference variable is pointing the implemented class object, using that reference variable, we can only access the methods declared in the second interface. So I2 ref, say IREF is an interface reference variable of second interface I2. Using IREF, when it points right to the implemented class object, you can call what you can call IREF.n3, IREF dot I2 reference variable is IREF. IREF is pointing implemented class object. Now the uh, uh, implemented class object is assigned to the interface reference variable. Okay. Yes, I2 is having the 5 methods M1, M2, M3, M4, M5. So all these interface only, or we can say only the interface methods declared in I2 can be accessible using I2 ref. But since I2 is extended from I1, M1, M2 can also be accessible using IREF. IREF.m1, IREF.m2 is valid. But in case if you try to create a reference variable for I1, when I1 is pointing the interface implemented class object, using I1 reference variable, we can only call M1 and M2, right? Let us check that first. Java C interface a2.java Java interface C. It's a second interface. I2's reference variable is accessible. The interface I1 methods because of inheritance. IREF.m1, IREF.m2 is valid. Suppose we try to create the interface reference variable for first interface I1. I1, say I1 ref is equal to IMPL OBJ implemented class object. Now let us try to call these methods. Now what happens? This is I1 ref. Small change. This is I1 ref, I1 ref, I1 ref, and I1 ref. File save. Compiling the file. We are having some getting some compile time errors. I1 ref dot n3 because I1 ref cannot access I2's actual interface methods. I1 ref can have the rights only to access its own interface methods. I1 ref dot m1, I1 ref dot m2 return. These are valid, but second interface methods m3, m4, m5 are not accessible using first interface reference variable. So commenting that line, then we will get the same result. Or not. But here I2 ref, when I2 ref is pointing the implemented class object, I2 ref can call interface methods I1 also because here we applied inheritance. Interface I2 extends I1. Because of that, I2 reference variable can have the rights to call its own methods plus the inherited methods of interface I1. Then the interface uses right to achieve a runtime polymorphism. As we discussed earlier, interface IX, one character variable is initialized, the method is declared, say IX test. Class C1 implements IX. IX test is redefined. For example, C1 class IX test is called. Then class C2 implements IX. Given the message, C2's class IX test is called. Class C3's IX test method is called. Only one interface method, say void IX test, which is redefined in the different classes, class C1, class C2, and class C3, with respect to their own implementation. Then using the interface reference variable, say IX ref. This is the interface reference variable. IX ref, right, can point the C1 object, then C2 object, and the C3 object. Then IX ref dot IX test. This calls the version available in the C1. The same statement second time, right, calls the version available in the second class because the object is currently pointing, the reference variable is currently pointing second class object. Same statement calls the version available in the third class C3 because IXRef is currently pointing the third class object, right? Here also I can write IXRef is equal to new phone IXRef dot IXTest or new C2, new C3 instead of assigning directly the implemented class object. Right hand side you can also specify new then a constructor name async, right? So in anyhow, right, in all these, right, are two possibilities in call one and call two. You will get the same result. Say interface 9 Java C, interface 9 Java, Java interface 9. Twice you will be getting the same result, right? Both in call one and call two, both are results in the same calls. Then interface in inheritance in interfaces, right? One interface can inherit the features in another interface. Interface 1i variable is declared, get char, get int methods are declared. Interface 2i extends 1i on byte variable, here get float, get long methods are declared. Since the interface 2i extends 1i, all features of 1i are available inside the second interface or 2i. So when a class say int int implements a 2i means what we have to do, 2 plus 2 4 methods must be redefined. So get float, say get long, and get can, get in. The additional methods of interface 1i, right, are also to be redefined because this is inheritance in interfaces. When the second interface, right, or when the interface inherits another interface, and when that interface is implemented in the class, the implemented class must redefine the actual interface methods plus the interface which has been extended from another interface, right? So two interface features should be redefined here. Otherwise, this class should be made as abstract class one. Now, using this implemented class object, you can have the rights to call all these methods: get float, get long, get char, and get in. If not, we can create a reference variable of 2i. Using a reference variable of 2i, we can point the implemented class object. Then 2i could be used to call all these four methods because get char, get int are also available in 2i. In case one i's reference is created, when one i's reference is pointing the implemented class object using one i's reference, what you have to do is you can only call get char and get int methods, right? This is inheritance in interfaces. when one interface inherits another interface, the role of implemented class is to redefine all methods in the two interfaces. In case if the implemented class fails to redefine any one of interface method, that implemented class must be made as abstract one. Right? Now see Java C interface data Java interface thing. The values are printed. Suppose the implemented class get int is commented out. Here let me comment out get int. See what happens. Compiling the file again. Int inh is not abstract and does not override the abstract method get int in one I. Get int in one I, right? What one? Get int in one I, right? This is not redefined in int inh and the class is not even made as an abstract one. So this results in the compile time error. So when the interface implements, when the implemented class uh, uh, fails to provide the any of interface methods, then that class should be made as abstract one so that it cannot create any object for the abstract classes.